Hello, students. Today we'll be going over Skill 6, factoring using a difference of perfect squares. Let's dig in. So, on our notes, we start off with a couple of examples. We are asked to multiply these binomials and then put our answers on blanks. These slides don't have a blanks, but your notes should have one for you. So, I'm going to go ahead and multiply these out. I'm going to use a box for the first one. I have an x plus 2 and an x minus 2. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x, and negative 2 times 2 is negative 4. This negative 2x and this 2x will cancel, which leaves me with x squared minus 4. On the second one, I'm going to use a distributive method. I'm going to distribute here and here. So 3x times 3x is 9x squared. 3x times 1 is 3x. Negative 1 times 3x is minus 3x, and negative 1 times 1 is minus 1. Again, these negative 3x and 3x will cancel. Leaves you with 9x squared minus 1. I hope you're starting to see a pattern here. So on our third one, we have 10x plus 7 times 10x minus 7. I'm going to do another box, just find it more enjoyable. 10x plus 7, 10x minus 7. 10x times 10x is 100x squared. This is 70x. 10x times a negative 7 is negative 70x. And 7 times negative 7 is negative 49. These two numbers are opposites. They will cancel. So I am left with 100x squared minus 49. So the question asks us, what did we observe about our binomials that were being multiplied? What I noticed is they are opposites. We have what we call conjugates here. We had same terms, let's erase that, same terms with opposite signs in the middle. What did we notice about each of these as we answered them? Think about the numbers that we had compared to the numbers in our binomials. Well, we ended with two terms, so we ended with binomials. That's what I noticed. A binomial. Our middle terms canceled out, so right here are 3x and our negative 3x, for example, and our number 2. They canceled out. And something that might not be readily apparent canceled out. Both of our terms that are left in our binomial are perfect squares. Both perfect squares with a negative sign in the middle. So we've established there's a pattern here. There's a pattern when these two binomials are multiplied together, as long as they fit this sort of shape that we have, right? But what does that mean? What can we do with this? Well, we can use what's basically a shortcut. It's called a difference of perfect squares. And the steps you're going to use are, first, we're going to make sure that we have a binomial, and then we're going to take out the GCF. We've talked about taking out the GCF since we started our factoring stuff. It's the biggest piece that can be removed from any one binomial or group of terms. If both terms are perfect squares, for instance, if we take everything out and we are left with a perfect square and have a negative sign between them. So once we've done this setup, we have a perfect square with a negative sign between them. You can factor that using a difference of perfect squares method. So we're going to move from this one binomial into two binomials that are being multiplied together. The first thing we're going to do is find the square root of those numbers. And then they're going to put those in your binomial factors. And we're going to make sure that one factor has a plus sign and the other has a minus sign. What does this look like? Let's go over a couple of examples. As we have come to do, established a delta math question that you will see on your homework and an SAT question that you're likely to see some form of on the SAT. So let's do our delta math one first. We have 2x cubed minus 32x. My first step is to remove my greatest common factor. These both share an x. I can take that out, and they're both even, which means that they share a factor of 2. So I can take 2x out. I'm going to remove my 2x, which leaves me with x squared minus 16 on the inside. So now that I have this two perfect squares, and you can tell that they're perfect squares because we're going to take the square root of them and get an even whole number, an integer. The next step is to take the square root. So I'm going to take the square root of x squared. The square root of x squared is x. And the square root of 16 is 4. I'm not going to worry so much about that minus sign in front of it. But now I'm going to write these two terms in my binomial factors. So I'm going to write two factors, right? Two factors. I'm going to write x and 4, x and 4. My final step is to put one plus sign in one of them and a minus sign on the other side. And now we're done. We have taken our, I'm sorry, forgot my 2x here. This 2x will need to come down with me. We have taken our one binomial and factored it into two binomials that are simplified. So how does this look like on an SAT? Well, we might be given something without being told that it is a perfect square or that we can solve it using a difference of perfect squares. But this form is exactly what a difference of perfect squares is going to look like. The question is, in the equation above, p and t are constants. Which of the following would be the value of p and t? Which means they're not variables. They have to be numbers. What we can recognize is that 4 is a perfect square, x squared is a perfect square, and 9 are perfect squares. And because there's a minus sign in the middle, I can use difference of perfect squares. So I'm going to use the same process that I used before to do that. 4x minus 9. I'm going to look to see if I can take a greatest common factor out. I can't. None of them share a variable, and 4 and 9 don't have a common factor. So I'm going to move forward. I'm going to take the square root of everything. I'm going to take the square root of 4, the square root of x squared, and the square root of 9. The square root of 4 is 2. The square root of x squared is x. And the square root of 9 is 3. So I'm going to write these in my two binomial factors. And you'll see that it ends up looking exactly like our example over here. 2x plus 3 and 2x minus 3. The plus and the minus can be on either side. You can have 2x minus 3 and 2x plus times 2x plus 3, and it will still give you the same answer. I just wrote it this way so that it matches our form. Now, if this matches, if these things match right here, I can replace our constants with p and t, and they should look identical. And they do, right? So now I'm just going to look for p and see what number p is. The value of p in both of these right here is 2. So my answer is 2. Now we're going to look at a harder example. A harder example is going to involve more than one step to factoring. Our difference of perfect squares only works with binomials. Right now, we don't have a binomial. We have a polynomial, a 4-term polynomial. But we know how to factor 4-term polynomials. We learned it, I think, in skill 1 or 2. Factor by grouping. We can group these. We have 4 terms, so we can group them together like this. So I'm going to do factor by grouping first. I've created 2 binomial factors, and I'm going to take out the greatest common factor of both of them. So the greatest common factor of my first part is actually x squared. They share an x. They actually share 2 x's, so I can take that out. The second binomial shares a factor of not 9, but negative 9. Negative 9. The biggest piece I could take out of that first term is negative 9. So what I am left with after rewriting is I write those factors in front with whatever is left inside. X cubed divided by x squared is x. 4x squared divided by x squared is negative 4. And then my negative 9x divided by negative 9 gives me negative 9 times x. And 36 divided by negative 9 is negative 4. And that's how we check to make sure that we've done it right. Our parentheses are surrounding two binomials that are exactly the same. I'm going to regroup these now. These two terms are going to come out in front, and these two are going to come together to create one binomial. So I have x squared minus 9 in front. That's going to get its own set of parentheses. X minus 4 is going to get its own set of parentheses. Now, in factor by grouping, we would be done. But one of the things we're going to have to learn to do is look for another step here. We have not used our difference of perfect squares. That's our hint right here. But if I look inside of what I've already worked on, x squared right here is a perfect square. And 9 is also a perfect square. They have a negative sign in between them, which means I can, again, factor. I can take a difference of perfect squares. So x squared, square root is x. 9 square root is 3. So I'm going to write this part, just this part, as its own set right here. X minus 3, x plus 3. And then I'm going to carry down my x minus 4 that was already here. This is now completely factored. I ended up with 3 answers. One of the hints that you can check is at the very beginning, my highest exponent was x to the third. That is the number of factors that you will usually have. So I had an x to the third, and I had 3 factors, 1, 2, and 3. So sometimes we may be required to do something before we can do our binomial factors. In our harder SAT example, we have an x squared minus 1 divided by x minus 1 is equal to negative 2. And the question is, what does x need to be to make this correct? Now, if you didn't know anything else about how to solve this, you could plug these answers in and get an answer. But we're much more clever than that. We're going to use our difference of perfect squares to solve this. X squared is a perfect square, and negative 1, believe it or not, 1 is a perfect square. So I'm going to do difference of perfect squares. The square root of x squared is 1, x, and the square root of 1 is just 1. So I can rewrite x squared minus 1 in my binomial terms. My binomial factors here is x minus 1 and x plus 1 over x minus 1, because I didn't take that away yet, is equal to negative 2. Now, this may not have looked like it helped a lot, but right now we have a term right here that is common. I can separate these two terms being, these two binomials being multiplied as x minus 1 over x minus 1 times x plus 1 over 1. When I multiply these back together, I will still end up, they are equivalent to x squared minus 1 over x minus 1. But if you look right here, x minus 1 over x minus 1, well, that's just 1. These all cancel out. That's 1. So now what I have is x plus 1 equals negative 2. X plus 1 over 1. Anything over 1 is just whatever's on top. So your numerator will always be dominant. I can now subtract 1 from both sides, and that will give me that x is equal to negative 3. And that's my answer. Now, if you didn't want to do all that work, you could have plugged and played, and it might have taken you more time, may not have. But this is a surefire way to make sure you got the right answer. So now we have some whiteboard practice. I know that if you are watching this video from home, you don't have a whiteboard, you can get some scrap paper. We're going to do just, I think, one of these. We will do number 3. So why don't you go ahead and take a second, and then come back, and I will solve this one. Okay, so hopefully together we can work this out. This is two terms, the first step is always going to be look for a common factor, greatest common factor here. They both don't share a variable, so whatever I'm taking out is not going to be a y if there's anything. They are both even, which means that I can take out 2. My first term is negative, so I'm going to take a negative out as well, because that's going to flip the sign. Negative 32 y squared divided by 2 is negative 2 times 16 y squared. And I'm going to also have to divide 50 by negative 2, and that leaves me with a negative 25. Now, I have realized that 16 is a perfect square, y squared is a perfect square, and 25 is a perfect square. So I'm going to take their square roots, 4, y, and 5, and I'm going to write them as two factors. And remember to bring down my negative 2 here. So I'm going to write 4y and 5, 4y and 5. One of them will be plus, one of them will be minus. Now I am factored. I can check again to see if there's another factor I could take out, but there is not. If you feel the need to keep practicing, you can do these other two whiteboards in addition to your IP. One other thing I want to talk about is solving these equations. Solving these equations means we're going to get answers, not just factors, but answers. And those steps are going to involve setting each equation equal to 0. I'm going to factor using my new difference of perfect squares, and then I'm going to set those factors equal to 0 and solve for x. And what this looks like is, with my example here, I have 4x squared equals 25. Now, to get this equal to 0, I'm going to have to move 25 to the left side of my equation. I'm going to do that by subtracting. And what I do to one side, I have to do the other. These will cancel. This leaves me with 4x squared minus 25 is equal to 0. Now I'm going to factor my left side using difference of perfect squares. Square root of 4, square root of x squared, square root of 25. We have 2, x, and 5. And you can use your calculator to verify these if you're not getting them. So I'm going to write that as two binomial factors. There we go. Still equal to 0. This is going to be plus. This is going to be minus. So I'm on step 3 here. And then my step 4 is to solve for x. So I'm going to set, or I'm on step 3 now. I am now on step 3. I'm going to set each factor equal to 0. So 2x plus 5 is going to be equal to 0. And 2x minus 5 is equal to 0. And now I'm going to solve for x. For both of them, I should get two answers. So this is going to become minus 5 on both sides. 2x equals negative 5 divided by 2 means that x is equal to negative 5 halves. And on this one, I'm going to add 5 to both sides. That's going to become 2x is equal to 5 divided by 2. And x will be equal to 5 over 2. I have two different answers, one negative and one positive. So if you're asked to solve these equations, you're going to set them equal to 0. We're going to go ahead and do this one together. Go ahead and take a second. And then we are going to work for it. Okay, so the first thing I'm going to do is set everything equal to 0. So to do that, I have to subtract 25 from both sides. That gives me 256x squared minus 25 equals 0. Believe it or not, 256 is a perfect square. You can check in your calculator if you don't believe me. But the square root of 256, I think, is 16. Could be wrong. But I'm not. So I'm going to take the square root of 256, square root of x squared, and the square root of 25. And now I'm going to write my binomial factors. 16 into x, and 16x and 5. equal to 0. Make sure one is positive and one is negative. So the last step here is I'm going to set these equal to 0 and solve them. It's actually 2 steps. X is going to be equal to negative 5 over 16, and this one is going to be equal to 5 over 16. And finally, we have an SAT that I want to give you guys a chance to try. Go ahead and pause the video, work on it for a few minutes. If you get stuck, come back and we will work on it together. Okay, so I have y equals x squared minus a. In the equation above, a is a positive constant and the graph is a parabola. Which of the following is an equivalent form of that equation? So we have removed the concept of finding out whether a is a perfect square or not. We cannot define whether a is a perfect square or not because we don't know what a is. However, if we just moved forward with the assumption that it is, we can factor this using a difference of perfect squares, right? If we assume that x squared minus a is a difference of perfect squares, a is a perfect square and x is a perfect square, my first step is to take the square root of x squared and the square root of a. Now, I don't know exactly what a is, but I can just write it as the square root of a. Okay? And I'm going to fill in my 2 binomial factors with whatever that is. So whatever I see on the right side here, I have x and the square root of a, and x and the square root of a. 1 plus and 1 minus. And if you look at this, this happens to match b. If you got a, what you did was when you took the square root of a, you got a again, which is not possible. If you got c, what happened was you divided instead of taking the square root. And if you did d, you didn't take the square root, you squared. Hope that makes sense. So now you have some notes to work on. Hopefully we filled out most of them. And you can begin your IP. There is a paper copy and a Delta Math copy. Have a good day. I will see you guys later.